Today we're going to be talking about section 5.4, derivatives of exponential functions. It's going to include a little bit of chain rule that we've talked about so far. You'll see some examples where we just take a derivative of the exponential function, some chain rule involved, product rule, quotient rule. It's going to be a good time. You might have noticed that you don't see me right now. You're seeing my son teach you about mathematics. So he's got a joke for you real quick, though. Go ahead.
Knock.
Who's there?
Banana.
Banana who?
Banana ate you.
Oh my goodness. All right, get out of there.
Okay.
All right, it's actually me. It's me about 30 years ago. So, exponential functions, e to the x power. Don't touch it. Can you see me?
Yeah.
You see the board? All right, don't touch it. So, derivative of the exponential function e to the x is nothing more than just e to the x power. It doesn't really change. If we start having a variable or a exponent that's more than just x, some type of expression, 2x, 3x minus 7, x squared plus 2x minus 5, then we start to see some chain rule where we take and we keep the original function and then we tack onto that, we multiply to that the derivative of whatever the exponent is. So a couple of real quick basic examples here to show you. If I have y equals e to the 2x minus 1 power and I want to take the derivative of that function, so dy over dx equals, notice we keep the function the way it was originally, e to the 2x minus 1. Then we multiply onto that the derivative of that exponent. So derivative of 2x minus 1, just 2. So then our final answer would be 2 times e to the 2x minus 1 power. Nothing too difficult.
Can I be in this now?
No, you have to wait.
Okay.
In our second example here, we now have an exponent that's a fraction. So e to the negative 3 over x power. You're thinking maybe, hey, we might have to do the quotient rule, but there's a way around it. Since our numerator here is a constant, it's a lot easier to deal with. So the derivative of that, f prime of x, keep the original function e to the negative 3 over x power. We want to multiply that by the derivative of that exponent. Well, remember, variable in the denominator, we can bring that up as a negative exponent, so we can actually call this negative 3x to the negative first power, which makes your derivative a lot easier.
We can't do 2x.
And that's okay. Bring the negative 1 down, we multiply it by the negative 3 there, so it becomes a positive. X to the negative second power. So our final answer then would be 3e to the negative 3 over x power, all divided by the x squared. So, any questions so far? Go back and just revisit the examples. Alright? Almost done. 2 more examples to go.
Okay, be in it now.
No, you have to wait your turn. Alright, here, f of x equals x squared times e to the 2x power. So here we've got a little bit of product rule. Alright, so if I take the derivative of x squared, that's going to be 2x. I'm going to keep my e to the 2x power plus keep my x squared. Derivative of e to the 2x is going to be e to the 2x power times 2. There's your chain rule coming into play. So what we're looking at here is this. 2x e to the 2x power plus 2x squared e to the 2x power. Alright. So we've got some stuff in common here. 2x squared, we could factor that out. But what might be a little bit easier, e to the 2x power, e to the 2x power. So we're going to take the e to the 2x out. So e to the 2x power, take that out, and we've got 2x plus 2x squared. There's our final answer for that. So then finally I thought I'd show you a little example here real quick on exponential functions involved in the quotient rule. So x squared minus 3x divided by e to the 2x power. So low D high. So e to the 2x times 2x minus 3 minus x squared minus 3x times the derivative of e to the 2x. So that's e to the 2x times 2. All divided by, you'd have e to the 2x, but you've got to square it. So remember, power to the power, just multiply the powers together. So that's actually going to be e to the 4x power. So, things that I would do, again, e to the 2x, e to the 2x. I'd probably go ahead and factor those out. So now I'm looking at this. E to the 2x times 2x minus 3 minus 2x squared plus 6x, all divided by e to the 4x power So I can combine my like terms here, and so my final answer looks something like this. We've got negative 2x squared plus 8x minus 3. Here, I can do some canceling. E to the 2x divided by e to the 4x is just going to be e to the 2x power. And that's my final answer. So a little exponential, a little quotient rule. Again, if you have any questions, go back and take a look at the notes again, the examples, and we'll be going over some problems in class here when you come in tomorrow. Alright? Anything you want to say? Psst, come here.
Okay.
Hurry up. Say goodbye.
Bye!
Ooh, say fractions are your friends.
Fractions are my friends.
No, fractions are your friends.
Fractions are your friends.
Alright, good job.
Hi, Freckles.